Oh, forgot to start. Okay, so please open MULTISIM. Have you opened? And log into your account.
Done, sir.
Shall I proceed?
Yes, sir.
Okay. So now click on create circuit. So you will get this window, the schematic. Got?
Yes, sir.
Yes, sir.
Okay. Now take from source. Okay. Take a DC voltage source. Okay. From the left corner, take DC voltage source, place it somewhere here, and give value 1 volt. Okay. So we are giving 1 volt DC as the input. You can change the name to Vin so that it will match with ours. Have you placed?
Yes, sir.
Yes, sir.
Now I need one inductor. So again, you can go to this side on passive. If you click on it, you can see the inductor resistor. So click on this inductor and place it somewhere here. And our value of that inductor is 2 Henry. So click on this 1 micro and change it to 2. Done?
Yes, sir.
Okay. Now next again I want an inductor. So I'll just copy this, or you can take from there, no issues. And the value is 1 Henry. So I'm giving it 1 Henry. Done?
Yes, sir.
Now I need one resistor. So I'm taking from here again, going to passive, clicking on resistor, placing it here. The value of the resistor required is 1 ohm. So change it to 1 kilo ohm. You change it to 1 ohm. Okay. Now I need 2 capacitors. So again, I will go here, click on the capacitor, place it somewhere here. But in our circuit, I need it to be rotated. So I will click on this rotate, and you will get like this. So the value of this capacitor is 1 farad. So I'll click on here and change it to 1 farad. Again, one more capacitor is required. So I'll just copy this, or you can take from there, no problem. And I am placing it here. Value of this capacitor is 2 farad. Up to this, done?
Yes, sir.
Okay. You can, if you want, you can just move it a little bit and all. Okay, so based on your, can make it neat. Okay. Now take one ground. Okay, and I will connect it down here. So ground also is connected. Now make the connections. Okay, so I'm doing the connections here. Okay, done. Done. Here. Here. Okay, done. So please complete the connections. After completing, let me know. So this was a circuit that was given in our question.
Done, sir.
Okay. Now what you have to do is click on this voltage probe and take a voltage probe and then connect it here, because our output is the voltage across the capacitor, correct? So that's why I'm placing the voltage probe there, and I am changing the name to VO. So it will measure the voltage across the capacitor. Is it done?
Yes, sir.
Now you can save this. So I'm going to save as, okay, electrical modeling, something I'll write. Question 1. Okay. I'm just writing like this. Whatever name you want, you name it. So electrical modeling question 1 I have given. So please save it. Once you are done, you let me know.
Done, sir.
Okay. Now what you have to do is, okay, change this interactive. You can see the simulation interactive to transient. Are you able to change? It will be by default interactive. Change it to transient. Done?
Yes, sir.
Okay. Now go to this settings configuration pane. You can see on the right top corner this wheel, that is the configuration pane. So open this configuration pane. So one window will be sliding. Got?
Yes, sir.
Okay. Now start time is 0 itself. End time you give as 30 seconds. Okay. Based on your circuit, it will differ. So you have to do something. Okay. So I am giving here 30 seconds, which means that I am asking it to simulate from 0 seconds to 30 seconds. Done?
Yes, sir.
Okay. Now click on initial conditions. So there it will be showing determine automatically. Change it to user defined. Initial conditions, change it to user defined. Done?
Yes, sir.
Okay. Now again, click on the inductor L1, and in the configuration pane, you will see a window like this. Are you getting this?
Yes, sir.
So click on initial current IC 0. So we are defining the initial volt because transfer function analysis we are doing. So I need the initial current to be 0. Now this inductor also initial current 0, capacitor initial voltage 0, this capacitor also initial voltage 0. Resistor no problem. For inductors and capacitors you have to change it to 0. Is it done? For L1 click on this. Okay. Check this box. That's it. For capacitor also, for this capacitor also. Is it done?
Yes, sir. Done.
Okay. Now save it. So everything is done. Now we might need to change something based on the graph. So now click on run and it will automatically show the graph. Okay. So this graph is very bad. It is looking bad because it will automatically choose the simulation time. So what you can do is go back to schematic, click somewhere on the, not on any element, somewhere on the graph, and click on the configuration pane. So here you will get like this, correct? Are you with me?
Yes, sir.
Now click on this maximum time step and click manual time step. Similarly, initial time step, you click on that and make it manual time step. Done?
Yes, sir.
Yes, sir.
Okay. Now just run this. So it will take little time. Okay. So because the now we have asked them to simulate for a very small time step. So it takes time. Okay. So up to 30 it will do. So wait for some time till it is completed. Are you getting this? So
Yes, sir.
when you're applying 1 volt, it is going up to 1.5 volt, then it is coming down slowly, okay, in 5 seconds. Then it is coming down slowly, slowly. Okay. Now it has reached the 7.5 seconds. Okay. So it will take some time. So we have to wait till it reaches 30 seconds. Okay, so based on the circuit, it will be different. Okay, the time taken to settle will be different. All of you are getting right?
Yes, sir.
Okay. So let it reach, then I will tell you what to do in MATLAB. So the same graph you should get in MATLAB using the transfer function we have defined, we have derived. So the multisim part is done. Okay, so this is what should be the output when you are giving 1 volt to the circuit. You should get an output like this. Is it clear? So if our transfer function that we have derived is correct, and we are using that transfer function in MATLAB, the same graph we should get there. You got the idea?
Yes, sir.
Yes, sir.
Okay. Now go to MATLAB online, or if you have MATLAB, you can open your MATLAB software. So matlab.mathworks.com, you have, right?
Yes, sir. We
Yes,
have.
sir.
Okay. So sign in online MATLAB or your own MATLAB you can use. So you can use your Presidency University ID. Okay. Click on open MATLAB online. Once you have opened, you let me know. Done?
Yes, sir.
Shall I proceed?
Yes, sir.
All of you have opened, right? Okay. Now, when you come back to our problem, we got this as the transfer function, correct? S square plus 3s plus 1 divided by 4s cube plus 4s raised to 4 plus 4s cube plus 7s square plus 3s plus 1. Okay. So there is something called how to give a transfer function. Okay. Suppose you have a transfer function as 1 by s plus 1. Okay. Simple transfer function 1 by s plus 1. Okay. Let me open a word. Okay. Suppose your transfer function is 1 by s plus 1. Okay, so this is our transfer function. Suppose 1 divided by s plus 1. Then here the numerator coefficient, okay, is actually 1. Only 1 is there, correct? Denominator coefficients are what? 1 is there, then 1 is there, correct?
Yes, sir.
Understood? Okay. Similarly, if I am giving some other transfer function, say T of s is equal to, okay, 4s square plus 3s plus 2 divided by x raised to 4 plus 2s cube plus 4s plus 1. Okay. So what is the numerator coefficients here?
4, 3, 2.
4,
4
3, 2.
comma 3 comma 2. Correct. What is the denominator coefficient?
1, 2, 4, 1.
2, 4, 1.
1, 2, no, 1, 2. After that, what? Is there any
4,
s
1.
square? No, no. S square term is missing here.
No.
Correct. So
0.
0,
0, 4, 1.
comma 4, 1. Is it clear?
Yes,
Yes,
sir.
sir.
Okay. So, for example, I am giving like this. Okay. So let me do this. Okay. So second one, first one, numerator is 1. Correct. Denominator is 1 comma 1. Okay. Now G I am going to write G is equal to TF numerator comma denominator. Then automatically this transfer function should come. Did you try? Not done? Yes or no?
Yes, sir.
Similarly, second one, if I am giving numerator is what? 4 comma 3 comma 2 and denominator is 1 comma 2 comma 0 comma 4 comma 1. Right. Then again, G is equal to numerator comma denominator. You will get the transfer function. 4s square plus 3s cube, sorry, 3s plus 2 divided by s raised to 4 plus 2s cube plus 4s plus 1. Is it clear?
Yes, sir.
So this is how you can define a particular transfer function. Up to this is clear, right?
Yes, sir.
Yes, sir.
Okay. Now I'm going to take a new script. So click on new script. So that a new M file will open. Got like this untitled.m.
Yes, sir. Got.
Okay. So first I will give CLC. What is CLC?
Clear all.
No. CLC is to clear the command window. Okay. So suppose this is our command window now, correct? Suppose I am giving CLC. What will happen is that it will clear the command window. Understood?
Yes, sir.
Now if I am giving clear G. Now left side you can see workspace, correct? In that G variable is there. Now I am giving clear G means that variable will be gone. Understood? Now if I am simply
Yes, sir.
giving clear, what will happen? All the variables will be gone. Understood? So that also is a good practice to give clear. Okay, which means that whatever variable is there in the workspace will be automatically deleted. Is it done?
Yes, sir.
Now I will give a command called close all. It is actually to close all the figures that are open. Okay, if some figure is open, it will automatically close all those figures. Okay, now coming back to our transfer function. So this is our transfer function. So what should be the numerator matrix? Numerator vector?
1, 3, 1.
Correct. 1, 3, 1. So I am giving numerator is equal to 1 comma 3 comma 1. Is it clear?
आता classes नहीं था को भी
What is the denominator polynomial? 4, 4, 7, 3, 1. Okay. So denominator or whatever variable you want, you can use. What is it? Can you tell me?
4, 4, 7, 3, 1.
4, 4, 7, 3, 1. This is what we got. Okay. You can give n equal to d equal to. Okay, I'm just giving whatever you want, you can give. So now I will get the transfer function g or h, whatever you want. H is equal to tf numerator comma denominator, so that the transfer function will be formed. Is it clear?
Sir.
Now I am going to define a time vector. Okay, I want between 0 and 30, correct? I want a very small step size, so I'll give 0.0001. So this you know, right? This instruction?
Yes, sir.
Yes or okay. Suppose t is equal to 1 colon 2 colon 7. What will be t? 1 colon 2 colon 7 means what will be t? 1
0 to
3.
30.
No. Here 1 2 7 I have given in the command window. So it will become 1 3 5 7. Is it clear? You
Yes,
Yes,
sir.
understood?
sir.
Similarly, if I am giving t is equal to 0 colon 0.5 colon 2, what will be the values? 0.
0, 0.5, 1,
Hmm.
1.52.
Correct. Understood. Similarly, I am telling to take a time vector from 0 to 30 with the step size 0.0001, so that it will become very good graph. That's why. Clear?
Yes, sir.
Okay. Now I want to find the output. Okay. So VO, our output is VO, is equal to step. Okay. Step input I am giving. Okay. So that is the command to find the step response. Step, our system H, comma, the time. Is it clear? So it will calculate the step response of the system for the time 0 to 30. Step response, why? Because we have given here 1 volt as the input. Okay, so 1 volt is a step input. Is this part clear? Is this instruction clear?
Yes, sir.
Yes, sir.
So now VO will have the output. Now I want to plot it. So plot P comma VO. I will give a line width so that you can see it properly, comma 2, so that some width will be there for the line. Otherwise, you will not be able to see properly. Now I am going to give grid so that the graph will come. I mean, the boxes will come inside. Then xlabel. All these commands I hope you know. Time. X-axis is time, correct? In seconds. Then y. What is y-axis? Output voltage, correct? So you can write VO. VO of t. In bracket, you can write volt. Title you give title, the output voltage. Is it clear? Or just okay, now save it. Okay, give some name. Maybe we'll give same name, electrical modeling Q1. Don't give space and all. Okay, save it so that in your folder it will be there. Done. Yes or no?
Yes, sir.
Okay, now just run. It will show the graph. That graph should be same as what we got in MULTISIM. If it is same, our transfer function is correct. Same only, right? Yes or no?
Yes, sir.
Yeah, sir.
Which means whatever analysis we did is correct. Okay, so this is the actual behavior of the circuit, and this is the behavior of the circuit when we modeled it using mathematics. You understood?
Yes, sir.
Yes, sir.
Okay, so one circuit I will be giving wherein you have to find the transfer function, then wire the circuit in MULTISIM of using the transfer function that you obtained, check in MATLAB. I'll copy paste this so that those who were not able to do can use this code. Okay, MULTISIM link also I'll copy paste. It's not come. Okay, let me copy once more. Control A, Control C. I hope you got an idea.
Yes,
Understood
yes.
the importance of mathematical modeling, correct?
Yes, sir.
Okay. I will give the link of MULTISIM also if you have not wired. You're able to see, right? All those.
Yes,
Yes, sir.
sir.
We can.
Okay then. Okay then. Thank you all. Any doubt in this?
No, sir.
No, sir.
Okay. So I will be, by this weekend, I will be giving one question. You have to do it before you come to the college. Okay. So 6th when you come, you have to submit it to me. Okay. So that is one part of the assignment. Okay then. Thank you all.
Thank you, sir.
Thank you, sir.